This lesson we're going to be looking at nets and surface area. And we're going to be talking about how can you find the surface area of a cylinder or a right rectangular prism. Right rectangular prisms, we've already worked with those, but we will refresh our memory on that. Cylinders will be a little bit new concept for us here. So first of all, when we talk about surface area is the sum of the areas of the faces of a 3D object. When we talk about a net is basically taking a three-dimensional object and unfolding it. So in this case, they're showing us the net of a cylinder. Net of a cylinder is basically going to end up being two circles and a rectangle. The two circles being the top and the bottom of the cylinder, the rectangle being the sides, if you will, of the cylinder. And what's going to happen when we do that for a cylinder is we're going to have our two circles and we're going to have the rectangle. So the book talks about a formula and stuff, but we're not going to be provided with a specific formula for how to find the surface area of a cylinder. We're just going to have to know what surface area means and then think about if we unfolded this cylinder into, we laid it flat, then, kind of breaking it down, what the different shapes would be. So again, we know the top and the bottom are going to be circles. The area of a circle, we have that on our reference sheet. So area of a circle is pi r squared. Okay. Now since we have two circles, we can say 2 times pi r squared, or you can do pi r squared times 2 if you want. Besides the circles, we have the rectangle. And the rectangle is one we got to think about just a little bit more maybe. Okay, so on a rectangle we know area of a rectangle is length times width. The question is, on this rectangle, which would be like the sides here of our cylinder, if we unfolded that, what would the dimensions be? Well, the one dimension would be just like the height of the cylinder. The other dimension, if you think about it, visually we talked about with a piece of paper, if we have a piece of paper representing this cylinder, if we kind of make this into a cylinder shape, and then you can see when we unfold this, this is our dimension we're looking at. So this dimension on this paper, and then that is actually the circumference of our circle. Okay, that's the circumference. So the other dimension here being the circumference, which we can write it a couple ways we'll talk about in a minute. So that's like circumference times height. Well, circumference, we have two formulas for circumference. And you can use either one of those formulas. We have one formula for circumference is pi times diameter. The other one is 2 pi r. So the question is, which one do you want to use? Well, here's my thought. With the circles, we already have an r. We already have a radius there. So I'm just going to go ahead and use the one that involves radius. So 2 pi r is the circumference, and then times the height. If you want to use pi times d times height, that's fine also. Okay? If you use that one, you're going to have radius on part of your formula, diameter on the other part, and that's perfectly fine. Just a thought is if we have radius on both of them, it's less things we got to keep track of when we substitute. So just to mention again, if I didn't mention it already, the formula for the surface area won't be given. We just have to think about what surface area means. We will be given the area of a circle is pi r squared. We will be given circumference formulas. We will be given that the area of a rectangle is length times width. So we have all the tools we need. We just got to know which tools do I need in order to complete this job here, basically. So if we look at the try it, they're wanting us to find the surface area of this cylinder. Has a height of 9.5 inches and a radius of 2.5 inches. So it's up to you how you want to do this. Doing a problem like this, if you'd like to, you can draw a picture. Drawing a picture doesn't have to be perfect, but if you just kind of draw an oval and then come down from that, and then kind of like you're going to draw an oval, only the back part we wouldn't see, so you can put a dotted line there if you want. Okay, and again, it doesn't have to be anything perfect, but maybe just a visualization here of what this shape's looking like. So our height's 9.5 inches, the radius is 2.5 inches. I'm going to use a different color here so we can kind of see that distinct from the other part. Again, the radius is only going to go halfway across the circle, right to the center. So this is what our cylinder looks like. Now we're going to find the surface area of this. So finding the surface area of this, I'm going to think about, I'm going to do this from scratch, what we just talked about, because that's what we'll be doing when we're doing this problem on a test, for example. We'll be doing it from scratch, the first time anyway. Once you've done it the first time, you'll have it on your paper and you can go with that the second time. Okay, so for a cylinder, one part we've got the top and bottom, which are both circles. Okay, so we're going to have two circles. And then we're going to have the outside part, which unfolds to be a rectangle. Okay, so we have circles and we have a rectangle. So for the circles, you've got your formula on the reference sheet. Area of a circle is pi r squared. And since we have two of those, we're going to multiply that by 2. Now it's up to you, you know, whether you want to put the 2 in the front, whether you want to put it in the back. It doesn't really matter. We're just multiplying all that stuff together. So that's the two circles. Then we've got our rectangle. So rectangle, again, if we unfold this, we're going to have one of our dimensions is just going to be the height of the rectangle. The other dimension is going to be our circumference. So we're going to do circumference times height. And I'm just going to modify slightly here. Instead of circumference, I'm doing 2 pi r. If you want to do pi times diameter instead, that's fine. Okay, that's again just recreating that formula, which we only have to do one time. We get that formula down on paper, then we're good to go. We can use that for all of our circumference, or all of our surface area of cylinder problems. Okay, so we look at our cylinder here, and the R again stands for radius, which is 2.5. And then the R stands for radius, which is 2.5. And then the height is 9.5. Okay. Alright, so what we're going to do is we're going to work this out. And what we're going to do for working this out is I've got basically two terms here. Okay, we've only got one plus sign. So we've got some stuff multiplied together plus some stuff multiplied together. What I'm going to do is simplify both of those terms a little bit. But what we're going to do is we are going to save our pi until the end. I like to call it saving your pie for dessert. Okay, so what we're going to do, this first set of numbers here, the pi I'm going to ignore for a minute. I'm going to do 2 times 2.5 squared. And again, technically, if we were working that out by hand, that would mean we would do the 2.5 squared first and then take that answer times 2. So if we multiply those, you should get 12.5. Now, we're not going to entirely forget about our pi here. We're going to just save it. Make sure we got room for dessert. Okay? And then the other part, same thing. We got some numbers here. We got a 2, we got a 2.5, and we got a 9.5 that we're going to multiply together. If you multiply those together, you should get 47.5 pi. Now, these are actually like terms. Just like if we have 2x plus 3x is
6x.
2x plus 3x is 5x. Okay? Same idea here. We can add these together. So 12.5 pi plus 47.5 pi. We'll add those together. So 12.5 plus 47.5 is 60. So this would be 60 pi. So if they asked us, like we talked about the other day, if they asked us to write our answer in terms of pi, that would be our answer, 60 pi. If they asked us to do something different, then we can work it out differently. So on this example, they've just got a spot for us basically to put 60 pi. But a lot of times they'll say use 3.14 for pi. They might say round to the nearest tenth or something like that. We're just going to act like they didn't even say to round, just to get an idea here. So 60 times 3.14. Okay, so 188.4. Now, with surface area, our answer is going to be in square units. So this would be 188.4 square inches. When we unfold it, when we fold it flat, how many square inches of material do we need basically in order to make this cylinder, is what we're talking about. Example 2, we're finding the surface area of a right rectangular prism. A lot of times we'll just call this a rectangular prism instead of a right rectangular prism. Surface area, so like how much cardboard would it take to make this box? Or in this case, we're covering this paper somehow without overlapping the paper at all. Okay? Usually we're going to have some overlapping, but that's okay. So what we're going to do, think about, we did this last year, surface area of rectangular prisms. Basically, we have some twins in a case like this. We have the top would be the twin with the bottom. They're identical. We would have the front would be a twin with the back, and we would have the side would be with the other side. Okay? So it's really 3 sets of twin sides is what we've got with our 6 sides on a rectangular prism. Or you can do them all 6 separately if you want to. Okay? So the book talks about a formula here. We're not going to have that formula, but that's okay. Basically, we're just going to look at this thing. Well, we'll look at it with the try it in just a minute here. So let's go to the try it, and then we'll come back and look at example 3. So the try it, they wanted the surface area of this prism. So like we talked about in a rectangular prism, we're going to have pairs of sides that are going to be twins. They're going to be exactly the same as each other, so identical twins here, I guess. So we've got the top and bottom would be one set. We've got the front and back, and we've got the sides. So top and bottom, Dimensions would be 4 centimeters and 2 centimeters. The 4 we can see on the top already. The 2 you'll see on the bottom. We know area of a rectangle, we do length times width. So 4 times 2 would be one of those. If you want to say plus another 4 times 2, you can. I'm just going to say times 2 because we have 2 identical top and bottom. So we get one of them, we double it, that would be the total area with the top and the bottom. We've got the front and back. I'm going to consider the front to be this rectangle here. So dimensions of that would be 4 and 3. So 4 times 3 would be one of them. And then we could take that times 2 because we have 2 identical, front and back. And then the sides. So sides, like over here, dimensions would be 2 and 3 or 3 and 2, however you want to say that. And again, we can take that times 2. If you'll notice the first part of these, basically it's every possible combination. The 4 gets paired up with the 2 and we double it. The 4 gets paired up with the 3 and we double it. The 3 gets paired up with the 2 and we double it. So it's all the different combinations is a way to help make sure you've taken care of all of them here. Then what we can do is just multiply each individual section and then add those together. If you are allowed to use the calculator, technically this is a setup that we could use and then go to our answer. You could actually type this all in your calculator at once. Other way, you know, would be just multiply. So 4 times 2 is 8, times 2 is 16. 4 times 3 is 12, times 2 is 24. And 3 times 2 is 6, times 2 is 12. And then when we add those together, we would get 52. So 52 square centimeters would be the surface area. In other words, kind of like how much material would it take to make this box. Alright, so if we go back to example 3, they're talking about a cube, literally cube, where all the sides are exactly the same. So in this case, we actually have 6 faces that are all identical. So the area of one of these, whichever one we want, would be 5/10 times 5/10. The deal is we have 6 faces that are all identical to that. And then if you multiply that, you should get, like the book has, is the 1 5/10 square meters. So that's going to be just a quicker process because all 6 are the same rather than having top and bottom, front and back, and sides like we did. They're all 6 exactly identical to each other. So a key concept, kind of recapping here about what it means to find surface area. They're just showing rectangular prism, but we can do this with really any three-dimensional figure. We're just doing cylinders and rectangular prisms here though. So if we look at the do you know how number 4, we'll get some practice with the cylinders again since we're a little bit newer to those. So surface area of the cylinder. Now this cylinder is very tired, so it's laying down here, but you know, if you want to turn this like this, you can. Okay? Understand is that when we talk about working out the surface area, the 10 is going to be the height of our cylinder. Okay? So if you've already worked out one problem, you'll already have a setup here. You got your 2 circles as 2 pi r squared. And then you got the 2 pi, what? 2 pi r h, right? Okay. This is our circumference times our height. Yep, that'd be good. Okay, so that's our formula we're going to be working with basically. Now when we look at this, question first of all, when we're substituting, what is our radius? 1. Good. So radius is 1, which we can go, you know, even though it's a simple calculation, so we don't just have a number appear out of nowhere here, we can call that our first step. 2 divided by 2 is 1. Okay? And again, the radius is 1, and then the height of this cylinder again would be 10. Okay? So that's got our setup started here. So if we work this out, 1 squared, 1 times 1 is 1. 1 times 10 is 10. And then we can simplify a little bit more. 2 times 1 is 2, so that'd be 2 pi. And then over here we could do 2 times 10. That'd be 20 pi. We're saving our pi here. So 2 pi plus 20 pi is 22 pi. That would be in terms of pi. The directions here say to use 3.14 for pi and round to the nearest tenth. So we'd be doing 22 times 3.14.
69.08.
Okay, so 69.08 nearest tenth would be 69.1. Square millimeters would be our surface area.